Let's look at another example of a line integral using Green's theorem. What we're going to do is first solve the integral using line integration and then use Green's theorem, and we should get the same answer. Now, the function you're supposed to integrate, you will find the integral along a curve around a closed path of x squared y dx plus xy squared dy. And you remember that this is the horizontal component because it is x that's changing, your dx, difference in x. And this is the vertical component because it's y that's changing, your dy, which is dy. Now, the region given is this. X is greater than or equal to 0, less than or equal to 1. And y is greater than or equal to 0, less than or equal to x. Now it's a matter of figuring out what region is this? What does it look like? Alright. Suppose we have an x and a y axis. We have 0, x goes to 1, so it's x axis. What happens with y? Y goes from 0 up to x. So you'll have to plot the graph of y equals x. Right? So y goes up from 0 up to x, but it stops at 1. So what you have here is this. So basically, Green's theorem is supposed to go around the region. This is a region from x equal 0 to x equal 1, and then y equals 0 up to y equals x. See that? Alright, so let's use the line integration method. That's the method we're going to do first. Now, of course, you remember with the line integration method, you have to break up the integral into individual parts. So this time we go, well, at first we go along x from 0 to 1. That will be along this path. And by the way, now that I remember, I'm going to ask you to write down the question and try the question both using line integration and Green's theorem. So have you finished? Well, you should be finished. Make sure you're finished, and then we look at the integration. Now, here, from along x from x equals 0 to 1, that's going to be along this line. And we're required, we're going to use a parameter to deal with it, alright? Now, along that path, x is 0. You can see that. dy is 0. X is 0 because it's on the x-axis. No, it's not x is 0. Y is 0. Right. It's on the x-axis. So you can see that y is 0. Right. Y is 0. dy is 0 because it doesn't go up or down. Now, using the parameter, let x is equal to t. So what happened with y? Well, y is 0. We know y, we know x, we know dy. What about dx? Well, if you differentiate to find dx by dt, you're going to get 1. So dx is equal to 1 dt. So what you have here is dt. Okay. So we can write the equation of a vector field using these. So we're integrating. We're going from 0 to 1 of, and remember this is going to be dt, because it would be dx, but since x is t, you say dt, right? Now here, so what we have here is x squared, which should be t squared, y, which would be times 0 dx, and dx again is 0, plus xy, so xy squared, oh, it is y is 0 and dy is 0. Let's do this again. Right, y is 0. So this part would be 0. This would amount to 0. All of this part would amount to 0 because it would be x squared times y, which is 0. This is 0 too. Alright? So it's plus 0 dt. So this part is 0. Alright. So you can see that. Now, the next thing here is that we're going to go from 0 to, what would it be? If y is equal to x, if you have y is equal to x, and x is 0, then y is 0 here too. And x is 1, then y would be 1 here too. Right? So if we go along, well, this would, the line here would be x equal 1. Right? Along x equals 1 from 0 to 1. Alright, so we see that x is equal to 1. Y changes, but what is dx? It goes straight up. Dx is 0 because x doesn't change. It doesn't move left or right. In this case, we have, let's make y equal t this time then. You can make x equal t or y equal t, you know, right? Now, if you make x equal t, you'd have to write if y in terms of x and see what happens with y. If you make y equal t, you'd have to write x equal and see what happens with y. When you make x equal t, then you say y equal, and whatever happens with x, whatever happened to x, it also happened to t. Alright, so y equal t, dy by dt would be 1, so dy equals dt. Okay, we have everything we want to substitute. So what you're doing here, you're integrating from 0 to 1, and remember the 0 to 1 is upwards along this line of x squared y dx, x squared y dx would be 1 squared times t dx is 0, alright, plus, and then xy squared dy, xy squared dy would be x is 1, y squared is t squared, dy is dt. Okay, good. So what happened here now? This part is 0, so you're integrating from 0 to 1 of t squared dt, which would be t cubed over 3 from 0 to 1. So that would be 1/3. Because when you put 1 over 3, you get, 1 cube over 3 is 1/3, and then 0 cube over 3, right? And then you get 0 in that case. Alright, so here, what? This y square, wasn't there a square? Y equals 0 for this. Oh, 0 square, right? dt. When I say y equal t, yeah, and then y square equal that. Alright, so now we have 1/3 for that. Now what we want to do is integrate along this line going down, y equals x. Alright, so just as a quick summary, just to make sure we didn't make any mistake, we went along x, and we see y is 0, dy is 0, x is t, dx is dt. Okay, good. So both of them become 0 because y is 0 and y is there in both cases 0. After that, we have along x equal 1, which is a line going up from 0 to 1. X is 1, dx is 0 because x doesn't change. If we make y equal t, then dy would be equal to dt. Alright? And then what you have is when you substitute, get x squared y dx, in this case 1 squared t dx. Oh no, a mistake. Dx, this is, if we say dx, oh yeah, dx is 0, right, it was alright, not a mistake. Y is equal to t, so x is t, y squared, oh, I made a mistake here now, x, oh yeah, x is 1, t squared. Just double checking, making sure. X is 1, y is t, so it's t squared. dy is equal to dt. Alright. So integral from 0 to 1 of t squared dt. Then we have t cubed over 3 from 0 to 1. Nice. It's 1 over 3. Alright. Now we're going along y equals x. Alright. Oh, by the way, these, you see, these boundaries, I didn't recheck the boundaries. They're going from 0 to 1. X is t. So x equals 0 to x equal 1. Alright, just to make sure the boundaries are alright, t would be 0 to 1. If I said y is t now, and y went from 0 to 1, right, then it means t went from 0 to 1 as well. Good, so the boundary is alright. Now, in this case, y is equal to x. Now, let's see what happens. if y is x, then we let x equal t. It means y is equal to t. It means the x by dt is equal to 1, so dx equals dt. And if we have dy by dt, it will be equal to 1, so dy is also equal to dt. Alright. So what happens after this? We would have x squared y dx. So we're going along x squared, which is t squared, times y, which is t, dx, which is dt, plus, and then xy squared dy, xy squared dy. X is t, so it's t, y is t, so is y squared is t squared, dy is dt. Okay. And the boundaries, when x is 0, we're going along up here when y is between y is 0 and 1, so we check. We say y is t, so it is t between 0 and 1 too, so it is 0 to 1. Alright, so the integral from 0 to 1 of, this is t cubed plus t cubed, this is 2t cubed dt. Alright, so when you integrate, you have 2t to the 4 over 4 from 0 to 1, which is 2 to 1, 2 to 4, 2. So it is t to the 4 over 2 from 0 to 1. When you substitute 1, we get 1 to the 4 over 2, minus when you substitute 0, we get 0 to the 4 over 2. So that is a half. Alright. So that's a half. Oh, by the way, it's 1 to 0 now. We're coming down. Oh, right. I have to be careful about this. It's actually 1 to 0. Right? So this one, it should be down here, and this 0 should be up here. If you trace the path that we move, right, we're actually going from 1 to 0. So it should really be 0 and this 1. This is 0 and this 1. But I have to be careful with, so careful with these, man. Because we're moving this way. We're going anti-clockwise, so when we move this way, y would fall from 1 to 0. Not 0 to 1, it's 1 to 0. So we're going up from 1 to 0. So it's going to be, upper boundary would be 0. 0 to the 4th over 2 minus lower boundary 1. 1 to the 4 over 2. So it will actually be negative half then. Right? So it's actually negative half. Alright, so the integral, if I call this int just to shorten the naming, let me call this int from now, so that I don't have to write back all of this. Integral is 0 plus 1/3 plus negative half. We add up all of them. 0 plus 1/3 plus negative half. Because what we're saying here is that along here it was 0, plus along here 1/3, plus along here negative half. Alright? So this is 1/3 minus a half. Alright. Common denominators 3, 2, 6, 2, 3, 6. Up top times 2, up top, up here times 3. So this would be what? 2 ones 2 over 6 minus 3 1 3 over 6. Okay, so what we have here is 2 6 minus 1 6, which will be negative but minus 3/6, which would be negative 1/6. So you get negative 1/6 as the answer. That's by line integration, right? Now, in an exam, you might be asked to do it by line integration or by Green's theorem or both, right? So you should know both. Now, we're going to do it by Green's theorem in the next video. But remember, with Green's theorem, you have to do part of it using double integrals. So I'll see you in the next video then.